Hola, pre-calc peeps. Today we are going to talk about polar graphing. Now, before we begin jumping into the polar graphs, let's remind ourselves of some good old-fashioned Cartesian graphs, such as x equals 3. Well, what does x equal 3 look like? And you're probably saying, a line. Yeah, but what type of line? Oh, that would be a vertical line because it's always x equals 3. And numero dos, what about y equals 1? Miss Gutierrez, that's a line. Yes, I know. What type? Oh, that's a horizontal line when y equals 1. Okay, so that's x equals and y equals. Now, when we jump into polar, what if I ask you to graph r equals 3? Well, what does that even mean, r equals 3? Well, let's jump to our polar graph paper here. And remember, that's just lots of gorgeous little circles. And we're looking right there. Okay, and so we want to find r equals 3. Well, where does r equal 3? Well, there's r equals 1, there's r equals 2, there's r equals 3. So it's literally this circle right here is what represents r equals 3. So this is a circle. And there's actually another graph that would be the exact same circle. Can you think of what it might be? If you said r equals -3, you are correct. r equals -3 is the exact same graph. Awesome. Now, just like we did with r, let's do number 4, and let's look at what is theta equals pi over 3. Again, we're going to draw out some polar graph paper. I'll just do 3 circles here. And we want to graph theta equaling pi over 3 for every single r value. So, first of all, we have our pole. That doesn't change. Okay? Pole. So, then we have, oh look, r1, theta pi over 3. r2, theta pi over 3. So, there's 2 pi over 3. 3 pi over 3. Okay? Then we can go backwards and go to -1, positive pi over 3, -2, positive pi over 3, -3, positive pi over 3. So what shape does this graph make? It makes a line. Okay, so those are the shapes that r equals and theta equals by themselves make. And just like with theta equals pi over 3, we can also say theta equals another angle measure will give you the exact same graph. And that other angle measure happens to be 4 pi over 3 is also the same. Okay, so hopefully you're feeling okay with r equals and theta equals. And now let's actually jump to some good stuff. As we get into some real equations, I'm going to put up some polar graph paper for you to look at. I know, really cool. So let's look at r equals 4 sine theta. And this is number 5. I did not number it. I'm so sorry. Please deal with it. Okay. Just like we did graphing when we were in Algebra 1, Geometry, Algebra 2, everything you graphed, you made an XY table. We're going to do the same thing here. And even though we graph using r theta, we're going to make a theta r table. So I'm going to start and go around the unit circle. We are going to go all the way around the unit circle. And you're probably thinking, are you serious? I have to go every single unit circle value? But guess what? The whole idea is you do it once or twice, know the shape, and you won't have to do it again. So we plug in 0. 4 times the sine of 0. What is the sine of 0? Oh, that's 0. Then we're going to go again. I'm going to go in degrees. 30 degrees. What's the sine of 30 degrees? You say 1/2. What's 1/2 times 4? That gives us 2. We are going to go all the way around. You're going to fill out 45, 60, 90, 120, 135, 150, 180, 210. 225, 240, 270. I'm going to run out of room. 300, 315. Shucks, I'll add another one over here. Theta r. And we'll add 330 and 360. Okay, so pause, take a minute, fill out all the r's by plugging into 4 sine theta, and then we'll come back and we'll graph. Okay, now that you've filled it in, we're going to check this. Compare it to mine, that's 4 over root 2, or approximately 2.8. 60 gives you 2 root 3, or approximately 3.5. Then we get 4. Oh, I'm going to stick with the decimals. 3.5, 2.8, 2, 0. Oh, then we jump to negative 2, negative 2.8, negative 3.5, negative 4, negative 3.5, negative 2.8, squeezing it in here. Coming over here, we have negative 2 and back to 0. Great. Let's graph. Now, looking at this lovely polar grid that they have for us, remember we have our pole, our axis right here. This is 0. They have it marked where everything is 15 degrees. Okay? So these are our degree marks here, and so on as you go around. Okay, so 0, 0. Guess what? That's the pole right there. Then we're going to graph 32. Okay, you can graph it 32. I like to say I'm going to go over to my circle with radius of 2 up to 30 degrees, and I'm going to graph right there. Okay? So, then I'm going to say, oh, approximately 2.8, 45 degrees, something like that. Then we go to 3.5 up to 60, right around there. Then we have a radius of circle 4, 90, 3.5, 120 degrees. That's going to be over here. 2.8, 135 degrees would be about right there. 2, 150 degrees would be right here. What is happening? Okay, there we go. Sorry about that. I have no idea what I selected. And then 0, 180, guess what? Circle radius 0. That's the pole again. Then if you started going negative 2, you're going to end up at the exact same point. In fact, going to your circle negative 2, so I go negative 2 to the left, and I go positive 210 degrees, is going to bring me right back to the same coordinate point that I have here. Okay? So that's going to be that point again. In fact, if I did negative 2.8, 225 degrees would have me back over here. There. So all the same points actually repeat. So then we look at this and say, oh, what shape does this make? Well, let's connect all of our points as beautifully as I can, and we have a circle. Okay, if you have questions, write them down, bring them to class. Let's go again. This is example 6, and we're going to do r equals negative 3 cosine theta. Okay, same idea. We're going to make a theta r table. So, go ahead, pause it, make a theta r table, and go all the way around the entire unit circle. Okay, I lied. You don't have to go all the way around the entire unit circle. But let's hit up 0, 30, 45, 60, 90, 120, 135, 150, and 180. Why did I not go any further? Oh, because it's probably going to repeat just like example 5 did. So pause it, fill in R, come back, here we go. Let's see. I plug in 0. I get negative 3. Negative 3 root 3 over 2, or approximately negative 2.6. negative 3 over root 2, or approximately negative 2.1. This is negative 3 halves, or of course you could write that as 1.5 negative. 90 is 0. This would be positive 1.5, positive 2.1, positive 2.6, and 3. Let's plot. Okay. Oh, negative 3, 0. That's the pole. Okay? Right there, our pole. Let's make this line a little thicker so you can see it. There we go. Pole. Okay. So then we have negative 2.6. So I'm going in the negative left direction, 2.6. And then I'm going to go 30 degrees positive, and that's going to bring me right there. Then I have negative 2.1, 45 degrees. Right there. Then I have negative 1.5. So going out here, that's 60 degrees. That'll take me right there. 90, 0. Hello again, pole. Positive 1.5. So I'm going to the right now, 1.5. And I'm going to go around 120 degrees. That puts me right there. 2.1 is going to be 135, about right there. 2.6, 150 is right there. And 3, 1, 2, 3, 180 has me right here. So looking at all those dots, what shape do we have here? We have another circle. So what changed? What made it different between the two? And what you should be thinking, what made it different, let me take that graph paper away, is notice. We have r equals a sine theta and r equals a cosine theta is a circle with diameter A. So when you have a sine theta, your circle is going to be on the y-axis. Okay? When you have a cosine theta, it's going to be along the left and right. So notice a sine theta I graphed up. What would make it flip to be on the bottom down here would be if we had a negative A. Or what would make it be on the left over here would again be a negative A. Okay, so hopefully you're feeling comfortable with circles and the generic form for circles. We will be moving on to much more exciting graphs of polar functions, after your quiz on polar coordinates. So study hard, and I will see you guys next class. Bye.